Okay, now we're going to take a look at a program that will blur an image, and the way you blur an image a little bit is by mixing it in with its neighbors. And we're going to have what we call blur factor here. And if the blur factor is 1, then we're going to take one row and column on all four sides here, and we're going to take the average of those 9 and store it in that pixel in our new picture. If a blur factor is 2, then we're going to go 2 pixels in each direction from this pixel and take the average of those 25 pixels, and when we get the average, we're going to put it in here. And then if the factor is 3, we're going to do 48 neighbors here, and 3 in each direction. And now it's going to take a while. So what we want to do is we are going to write a function, okay? And it will accept an image, an x-coordinate, and a y-coordinate, and the blur factor will return the average of the RGB of the pixel and its neighbors. Okay, so let's just take a look at this one here. If it's a blur factor of 1, we're going to go from -1. Let's do the x first. So this cell right here is x minus 1, this is x, and this is x plus 1. X minus 1, x plus 1, x minus 1, x plus 1. If we do the y direction, this is y minus 1, y plus 1, y minus 1, y plus 1, y minus 1, y, and y plus 1. So what I'd like to do, if the blur factor was 1, it wouldn't be a whole lot of code, I guess, but I still would have to do all 9 of those, get all 9 of those separately. And down here I'd have to get 25 of them separately, and here I'd have to get 49 of them separately. And so it kind of sounds like maybe there's a better way to do that. Maybe we could do a loop that starts here. It'll be easier to figure out on the big one here. Starts here, and then either goes across, and every time I get to a new pixel I just add on the red and the green and the blue. And so I have some running totals for those 3. And so the y stays at 0, or actually it'd be -3 from my starting point here. So it starts at y minus 3. X starts at x minus 3, and then I go to x minus 2, x minus 1, x plus 1, x plus 2, x plus 3. And then I add 1 on to and go to the next y row, which would be this y minus 2. And I go to x minus 3, x minus 2, x minus 1, x plus 1, x plus 2, x plus 3. Okay? And I'm going to do that across every row. So I'm going to have a loop, an outer loop that gets executed 7 times, and an inner loop that gets executed 7 times for a grand total of 49 times. So this is going to take a while when we run it. So we might start off with one of these smaller ones here first. So you need to identify the coordinates, and it's probably not a bad idea to just write them out by hand first so you can see what's going on. And so in this case I'm changing the x from x minus 1 to x plus 1 if I do a row at a time, and then it's going to be x minus 1 again, y, x plus 1, y. So the y stays the same here because I'm on a row. Here the y will stay at y plus 1 because I'm on a row. Here the y stays at y minus 1 because I'm on a row. Okay, so let's take a program, and I'm going to go back over, and I just finished working on a program here. Let's try that again. They put a border around an image, and we'll just take the same image here. We don't need to know anything. Before I do this, I'm going to do a save as, because I don't want to mess up my border program. So let's do a save as, and I'm going to save this as, I'm just going to put it on my desktop for right now, and I'm going to call this blur. Okay, and click on save, and so now it's got a new name, and I don't need this anymore. Actually, I'm going to leave that because I do need to have a question, and I need to know what should the blur factor be. Okay. And I don't need to divide that by 100, and so I'm going to call this blur factor. Okay. And I'm going to leave these because I like those better than image.size sub 0 and image.size sub 1. And what I'm going to do is I'm going to have a loop here, and I'm going to visit every X and Y. Okay, and so I don't need this because this has specifically to do with borders. So I'm going to do an R comma G comma B equals image dot get pixel, and then I give it the X and the Y coordinate that I'm currently on. So whatever X and Y are right here. Okay. So I'm going to get the pixel, and then what I'm going to do is I'm going to get the average of that. And so I'm going to, what did we say we were going to call the function? We didn't say we were going to call. Oh, we did. Program's called blur. It doesn't say. We'll call this, actually we may as well just call it average, I suppose. So I'd like to put functions up here at the top. They have to be defined before you can use them. So, and we'll call it average. And we're going to pass in an image. And then we're going to pass in an X, and we're going to pass in a Y, and we're going to pass in the blur factor. Okay, I'll hit enter a few times here to open up a little space. So what I want to do is I want to keep a running total of the red, a running total of the green, and a running total of the blue. So I'm going to do R total equals G total equals B total equals 0. So I'll initialize the totals to 0. And then I want to visit every single pixel surrounding the pixel at locations X and Y. Okay. Well, the blur factor is 1. I'm going to go from X minus 1 to X plus 1. So if the blur factor is 2, I'm going to go from X minus 2 to X minus 1 to X plus 1 to X plus 2. So my blur factor tells me where to start and where to end. So I'm going to need a nested loop here. So for, let me see, I don't want to call them X and Y because X and Y refer to my center pixels. Everything is going to be relative to those two pixels. So if I go back over here and look at my picture, you know, X and Y are going to be right here. I don't want to move those while I'm working on my blur factor. So I'm going to have another variable. Let's say it's like X2 and Y2. And let's, X2 in the range. Okay, and where do I want to start? I want to start at X minus the blur factor, and I want to go to X plus the blur factor. So remember, if you put two arguments in here, this is the starting and this is the ending, but it never includes the end, so I got to do a +1 on that as well. And that should take me from the leftmost pixel to the rightmost pixel. And then while I'm moving across a row here, on each one I'm going to set my Y2 in range, and it's going to be from Y minus the blur factor, comma, to Y plus the blur factor +1, so we don't stop too soon. Okay, and what do I want to do every time I visit one of these? Well, I want to get the pixel. So R comma G comma B equals image dot get pixel, and it's going to be X2 comma Y2. If I did X and Y in there, I'd just be getting that center pixel all the time. So I want to go to X2 and Y2 and get the pixel. And then I'm going to do R total equals R total plus R. And I want to do G total equals G total plus G. And I want to do B total equals B total plus B. Okay? And so if the blur factor is 1, I will still do this 9 times. If the blur factor is 2, I'll do it 25 times. If the blur factor is 3, I'll do it 49 times. And when I fall out of both loops, which would be over here, I'm going to be all the way back to the first 4, then I can compute my averages, okay? And so how do you know what to divide by? Well, I'm going to take my R total and equals R total divided by, and what do I divide by? Well, the blur factor is 1. You know, we have 1 on each side. So I take the blur factor times 2 and add 1 to it. So blur factor times 2 plus 1. So if blur factor is 1, then 1 times 2 is 2 plus 1 is 3. Whoa. I got to square that, don't I? So let's okay, so that should work. If blur factor is 2, then it's going to be 2 times 2 is 4 plus 1 squared is 5 and then squared is 25. If blur factor is 3 times 2 is 6 plus 1 is 7 squared is 49. So yeah, that'll tell me how many pixels I've actually visited. And I'm going to do the same thing for the green total and the blue total. So I'm just going to copy this and paste it in twice, and then just change the G, R to a G, and then change the R to a G here, and then down here change the R to a B. So I do my blue total and B. Okay, now I've done all the calculations I need, and you might be tempted to say, well, I'm done with my function, but you're not. What you have to do is you have to return that triple. So return, spell it right, the triple R total, comma G total, comma B total. And actually those probably are not very good names for those because they're not the totals anymore after we divide them. They're actually the averages, but I can always come back and fix that later. And it looks like there is something it doesn't like here. Let me see, am I off by a column? I think I'm off by a column. It says inconsistent indentation. So hit the tab key here. Back up twice. Yeah, I was off by 1. So if I do that, that should fix everything. Okay. Now, I can't update the picture in place because if let's go back over here and take a look at our little diagram. So if I update this, and then I go to blur the next pixel, well, I've already blurred this one, so I'm not going to get the original value for this one. And so you have to blur it and then save it in a new picture. Then blur the next one, save it in a new picture. And by the way, I just realized something here. We probably don't want to start, we could do this, but it'd be a lot of extra work, and I'm trying to keep this simple. So you don't want to start in the upper left-hand corner here of your picture because you can't blur it. There's nothing on the top and the left to blur it with. There's only stuff down here on the bottom and on the right. So you should probably go in, 1 plus whatever the blur factor is. So here, if I started up here, I'd want to start in row 1 and column 1. If I'm doing this one, I'd want to be in 0, 1, 2. I'd want to be in 2 and down 2. And here I'd want to be over 3 and down 3 before and I'd also want to stop at the other end as well. So let's go back in here, and we're going to have to make some changes here. So my range here is going to start at blur factor, and it's going to go to width minus blur factor. And here I'm going to go, I'm going to start at blur factor, and I'm going to go to height minus blur factor. Okay? And so that should, if I'm calculating correctly, that should keep me from going off the edges of my picture. I also need to create a new picture up here for my new blurred version. So we'll have something called image 2. New. And okay, it wants the mode, which is RGB, and apparently that has to be in caps. And the size is going to be a pair that is the width and the height, X first and then the Y. Now if I use those variables there, I better define them first. So I'm going to take these two lines here and I'm going to cut them out, and I'm going to go up here and paste them in before. Okay, and then I got to give it a size, and this I'm sorry, I've got to give it an initial color. I just gave it the size, and we'll do 0, 0, 0. Okay, now if we do that, we're going to have a thin black border around the outside of the picture because we're not starting right at the edge. If the blur factor is 1, we'll have a 1 pixel border. If we start at 2 for a blur factor, we'll have a 2 pixel border, and if we do 3, we'll have a 3 pixel border. So that gives me a blank black picture that's the same size. And now that I've gotten, whoops, I didn't call average here. So once I get the pixel, then I'm going to do R2, comma G2, comma B2 equals average. I got to pass in the image, comma the X, comma the Y, comma, and the blur factor. Okay. And they will return the average red, the average green, and the average blue. And then I want to take those and I want to put them in my image2. So image2.put pixel, and I want to send it my current X and Y, which is a pair, so I got to put them in parentheses, X, comma Y. And then the other thing that it wants is the new value. So R2, comma G2, comma B2. And then down here, I'm going to do, I'm doing an image show up here. Down at the end here, I'll do an image2.show. Okay. Now, since my programs rarely work the first time, chances are we're going to run into some bugs here, but that's fine. We'll fix them if we have them. So let's go ahead and run this. And I don't want to show that every time, so let's go ahead and run. And so it shows me my football, and what should the blur factor be? I'm going to start off with 1. It might be kind of hard to see if we're blurring it, though, with that. And, okay, so float object cannot be interpreted as an integer. And what am I doing? I input blur factor as a float because last time we did it as a float. So let's stop execution, and let's select float there and just convert it to int. And now let's give it another shot. So let's go ahead and check out our picture here. And then the blur factor is going to be 1. And we'll hit enter. And now that's our original picture. It shouldn't take too long to do 1, but it is going to take 9 times as long as it would take just to step through the pixels, because we've got all that. We've got 9 pixels to check for every pixel in the original picture. And it doesn't help that this picture here is also kind of blurred, you know, due to a depth of field problem. But the stuff down here is pretty sharp. The football's pretty sharp. So that stuff should be blurred a little bit. Okay, and here it is. And I can see a difference. If you look at this stuff down here, it's really crisp. But if you look at that same stuff down here, especially the white, you can see it's not nearly as sharp. So believe it or not, actually pretty much once we fixed that floating point error, it pretty much worked the first time. Now I'm going to run it again, and this time I'm going to tell it I want a blur factor of 2, and I'm going to hit enter. And since this is going to take longer, I'm not going to sit here and wait on the video. I'm just going to flip back over to the original picture here, and I'm going to pause the video, and when it's done processing, then we'll take a look at the newly blurred picture. Okay, we're back. This is the new picture, and let's look at these side by side. And now I think it's pretty obvious that we've got some blurring going on here. I didn't pay much attention to the football with a blur factor of 1, but you can tell that the football is blurred. You can tell the grass is blurred. These lines are blurred. So it's working. And I'm going to try it one more time with a blur factor of 3. And again, this is going to take twice as long as before, so it's going to probably take about 4 minutes, I suppose. And put a value 3 in there and hit enter. And so there's my original, and I'm just going to pause the video here, and we'll be back when the video is, or the program is done processing. Okay, here we are, and this one is with a blur factor of 3, and if you look at the pictures, can I do this side by side here and see what we get? Well, I'm not sure which one is which now. I think this is the blur factor of 3. But there's an easy way to find out, I suppose. Let's look at, well, it's not the one with the border around it, we know that. Let's take a look at this one, and that's not it. That's our original. Let's try this again. Actually, that's what I should have done. Yeah, let's go up here and do them in quarters, and come on. Well, it's supposed to go in, there we go. Yeah, drag it right up to the corner, I guess. See, there's not much room. Okay, I'm going to drag this one down to the corner. And which ones do I have? I don't know which ones I have. Okay. Well, that looks like the original. I'm not sure there's a lot of difference between this one on the right and this one on the bottom left. Let me go and try. Yeah, that one's definitely not blurred, or not blurred very much. That one, and nor is that one. So what I've got here then is, this apparently is the blur factor of 3, and it is clearly blurred. You know, obviously we could do bigger numbers than that. It would take quite a long time to run those, but this should work for you know, any reasonable blur factor. And the reason for making a video of this program is I wanted to show you how to write a function, and you know, how to step through the neighbors to a pixel. And we need to be writing more functions, and this will allow us, this is an example of kind of what we'll be doing in the future. So function should do one thing. It should pass in some variables, some parameters, and you should only use those parameters in here or any variables that you make up. Don't reach out here and try to use image2 or something like that that's available outside of the function. Just what's passed in and anything that you make up. Okay. I could have, one little minor change here, I could have written this as equals // and that just means if you got the same thing on both sides, so I got R total equals R total, and it does not, apparently you can't do that with integer. You can do that with integer division. You can do that with plus, minus, the asterisk, and the slash, but apparently it doesn't work with integer division, so we won't be able to do that. So, you know, the main program is pretty short. You can look at the main program and you can pretty much tell that this does what it's supposed to do, and that's what you want. You want to keep your main program so short that by looking at it you can tell for sure that it works. And you kind of want to do the same thing with every time you write a function. You want to keep the function relatively short. It should do one thing, and you know, hopefully it's short enough that you can look at it and you can pretty much tell, yeah, it does what it's supposed to do. Okay, so that's the end of this video.